Hi, today we're going to look at Chapter 2, Lesson 1, which is talking about variables, constants, algebraic expressions, and just evaluating. It is located in your textbook on pages 50 to 53, so if you want to look at your textbook and follow along with the video, you can. We have 4 definitions from this chapter. We have variables, which are just basically the letter or that symbol that's in an algebraic expression. Constant is a quantity that does not change. So if you have in your algebraic expression x plus 3, the 3 is the quantity that's not going to change. That x is our variable. That we can plug any number into that x and that number can change. So the variable is the letter that we are using as that symbol. The number that's in the problem is the constant, which doesn't change. Define algebraic expression, and that's just a math problem that includes a variable. We talked about numerical expressions last week, and the difference between an algebraic expression and a numerical expression is the numerical expression just has numbers and symbols. The algebraic expression is going to have that letter or the variable in it. That's what makes it algebraic. You're going to see the words define, evaluate. Whenever you see evaluate in a problem in your textbook, that just means to solve for the answer. Okay, here are some different ways that we will see multiplication. In algebraic expressions, we don't want to use the x for multiplication. We don't want to say 3 times x. That's a little confusing. So instead of using that multiplication symbol like we're used to seeing, you're now going to see these different ways that we can write multiplication when we're dealing with algebraic expressions. You're going to see 3 parentheses x, or any variable, not just x. You might see the parentheses next to the letter or the variable, and you may see parentheses around both of the pieces. So any of these that have parentheses with a letter next to it or a number smushed up next to it, that just means multiply. So we would say 3 times x, 3 times x, 3 times x. Also, if you have no parentheses with just a variable smushed up next to a number, that also indicates multiplication. Also, we have the dot, 3 dot x, that means 3 times x, multiplication. For division, we would have your traditional division symbol, like we're normally used to seeing, 3 divided by x. You also may see 3 divided by x written as a fraction. So now when you start seeing fractions in your math problems, that is an indicator that it is a division problem. Next, we're going to find the missing value in the table. We have w, our variable. We're going to use 55 for w, 66 for w, and 77 for w. We are going to substitute in whatever letter is in this w column for w in the problem, which is w divided by 11. So if we have the problem w divided by 11, and I want to substitute in 55 in the place of w, all I'm doing is putting 55 in that spot, divided by 11, which is 5. So now I have my answer is here, 5. If I were to put 66 in the place of w, I would have 66 divided by 11, that's my original problem, and that would equal 6. So I would have 6 in that box to indicate that would be the answer of that one. If I'm plugging in 77 in the place of w, I would have 77 divided by 11, which equals 7. So I would put 7 in the box. Let's look at another example of that. Find the missing value in the table. Well, this one is length, width, length, times with. Remember, our parentheses means we're multiplying when we have a letter or a number sitting outside of those parentheses with no operation signs. So that's just length times width. So my numbers are a little, something happened here, but that's a 4, 2, and an 8. So 4 times 2 is 8. If I know my length is 5 and my width is 2, I'm just multiplying. 5 times 2 is 10. My length is 6, my width is 2. I do length times width. 6 times 2 is 12. And now I have a length of 7, a width of 2. Length times width, 7 times 2 is 14. Another way you may see, rather than having in a table where it tells you what the variable is, it's going to give you sometimes something that looks like this, where our problem is 3 times h plus 2. And then it tells you 4h equals 10. That just means we're substituting 10 in for h. It tells you to use 10 for h. So we're going to put that 10 in there. So we have 3 times 10 plus 2. 3 times 10 is 30, following order of operations, plus 2 is 32. So my answer for that one would be 32 if I'm using 10 for h. You may see the word if. So sometimes we see for, sometimes we see if in our book or on a worksheet or a test or a quiz or anything that you're viewing. So we're going to substitute in 10 for h again. It's the same problem. Here's my problem. If h is 10, then what is this solution going to be? We have 3 times 10 plus 2. So 10 times 3, 30, plus 2 is 32. You should have a few try-its on your Cornell Note handout questions that were given to you. Go ahead and try those and put those in your notes, and we will look at more examples tomorrow in class.